video, we're going to consider a reliability demonstration test. So in other words, we're going to explore how many units we need to test for how many hours in order to demonstrate a specific reliability target that we've been asked to. So we launch Weibull++, and then we scroll down to Test and Planning, right-click, and we can see we have a number of utilities available in Weibull++, as well as the add-on, in this case installed in Weibull++. So like test design and target reliability, measurement system analysis, gauge R&R, and so on, maintenance planning belong to the native configuration of Weibull++. Alta test plan belongs to the life stress add-on, and the last three remaining, continuous growth planning, discrete growth planning, and repairable system test design, belong to the reliability growth add-on. So we opt for the first one, test design, and we have three analyses. We have a reliability demonstration test design, which is the one we're going to explore, or expected failure times plot, or different detection matrix. So we go for the first one, and as we can see, the layout of the page is totally different from the traditional Weibull++ analysis, because here we have a series of questions to which we have to either select the appropriate option or input a numerical number. So the first question is what we would like to demonstrate. We want to demonstrate either a specific reliability at a specific time, or we want to demonstrate a mean value, a mean MTTF. So we'll opt for the reliability at a specific time. What value of reliability? We'll leave 90, but obviously we can change it. What confidence level? Perhaps we'll reduce this down to 60. And at what time? Say, for example, 12,000 hours. So we want to demonstrate a reliability of 90% with 60% confidence level at 12,000 hours. And then the second part of the question is the failure rate behavior of our product. So we can either attach an analysis that we've carried out to determine the model and a parameter, in this case a shape parameter, or we can either opt from the pull-down menu, two parameter Weibull, a normal, one parameter exponential log normal, and then we assign what we consider to be a reasonable value of the shape parameter. In this case, we leave this as it is. And the final part instead is what we're trying to solve for. So we are trying to solve for a test time. So in other words, how many hours we're going to test our unit. And obviously we've got to supply how many units. So if, for example, we have 20 units available, and it will calculate the test time for the 20 units. Alternative, say we have a test time available, say 3 months, so 2,160 hours. We wanted to calculate the number of units that we need. So we calculate, and it tells us 269. Obviously, that's not a number. It's going to be very easy to convince anyone to supply us with in terms of sample. But what this utility is particularly useful if we can somehow accelerate. In other words, if we have, say, usage acceleration, so we can increase the number of cycles, this becomes very useful. Say, for example, even a small acceleration of 5, then it brings it down to a more manageable sample size. So if we can set up our test design so that the acceleration is approximately 5, it simply tells us we need to provide 11 units, and if these 11 units operate for 2,160 hours, we will demonstrate a 90% reliability at 12,000 with a 60% confidence band, on the hypothesis that the failure rate behavior of our product follows a two-parameter Weibull with 2 as the beta value of our product. Alternatively, obviously, this is basically pins us to a specific solution, but what we can do also, we can click on this reliability demonstration table, and we have a sample size from 1 to 10, and the number of failure. We haven't explored the number of failures so far, so we just create this table, and here is our table. So we have a sample size of 10, and it simply tells us basically, say if you got 10 unit and you're running 10 units at 2,238 hours, then none of them must fail to demonstrate the reliability target that we are proposing. But what happens if it fails? Say, for example, if we incur in a couple of failures, so we go into this column, then in which case we still start with 10, but only 8 of them will get to the end, but we have to test for 4,358 or 4,359. So obviously it gives us some alternatives so that we don't sort of throw away our test completely simply because one unit has failed. But we have to bear in mind that the requirement from 0 failure to 1 failure, 2 failure, and so on obviously changes in terms of the number of hours we have to test. And at the same time, we also benefit from the fact that as we are collecting failures, those failures, say for example these 3 failures, if we are incurring in 3 failures, will help us to demonstrate will help us to get a better understanding what is the failure rate behavior of our product under test condition. Thank you for watching.